Docker storage, more specifically bind mounts and volumes. So in this chapter we are going to discuss what exactly is the importance of the Docker storage specifically for persisting data which can be shared across different container instances. So there are majorly two ways. What are the benefits of each? What are the limitations? And of course the syntax for all of them we are going to cover. But first let's understand why do we need Docker storage. So for this I prefer beginning with building a simple console based application. I would like to practically demonstrate the limitation and then provide you the solution to the problem. So let me begin with creating a folder, let's say storage demo, and I create a new .NET console application. Of course, I would like to open this in Visual Studio. Code dot VS Code, and I would like to simply copy this program as it is and paste it in my program.cs. So open program.cs, select all, delete and paste. Now what is this program doing? A very simple program actually. When the main executes, I'm declaring a counter variable, declaring a file stream, and I'm trying to frame a path that is in my current working directory, creating a file by name counter.txt, and yes, just for the demo purpose, printing file. Now the purpose of using path.combine is it should work on both Linux and Windows. I did not want to hard code C colon or maybe front slash, not the backslash but the forward slash. I did not want to use that. And then I have created here a file stream object, trying to actually see if the file is existing and we can open. If the file is existing, trying to read from that file a integer value and storing that in the counter. But if the file is not existing, it throws an exception. I'm catching the exception, checking, creating a new file and setting the counter to null. That means either the file is opened or created as a new one. Incrementing the value of counter, displaying on the console window, and going back to the root of the file. In case we have read the file content here, we go to the root of the file, the beginning of the file, create a binary writer object, and we are writing that counter again back to the file and closing the file. That's it. So very small program. Now if I execute this program locally on my machine, I can see the output here. The counter is 1 when I execute first time. And of course the file should have been created. You can check that file over here, counter.txt. Because it's a binary file, okay, the extension binary should be used instead of txt. So let me change this. I'll call it as maybe bin. So run it once again. Again it will give me value 1 only because it's a new file which gets created. Run the same program second time, Control F5. It reads 1, increments by 1, becomes 2 and writes 2. Run once again. Between different execution instances, the value is retained and we are able to continue from where we stopped. Now let us try to create a Docker container from this, for which I'll have to begin with creating a Docker file. Now in Docker file, we need to provide all this, and we have learned the meaning of it before. Just that this name should be changed. Whatever is your current project name, that you have to give here storage demo, the folder name, because that becomes the DLL file name. So this is the one which is going to execute. Fair enough. So now go to the terminal window. And here let's build a Docker image. Docker build -t, let's say Sandeep Soni / storage demo space dot. That's the Docker image I'm creating. It takes a while because it has to do the restore, and once done we have the Docker image ready. Now once I have the Docker image ready, I would like to run the container instance. But what we have to note is every time I run the container instance, Docker run /storage demo, I'm going to get the output /app, counter is 1. Good. Now run it once again. Again we get 1. That means every time we are running the application, we are always getting 1. Now what is the reason behind it? See, the problem is every time a new instance of the container is created, a new file system also will be created in that particular container. And once the container ends, all that data which we have stored on the file system of that container is going to get destroyed. That means the whole file system is completely removed. And every time we run it freshly, yes, again a new thing happens. So this is the basic problem what we have. Of course, the only way we can overcome this particular problem is every time we create a container instance, once the container is terminated, from the terminated instance I create a committed image, and that image I use for executing second time. That means every time from the container current state we should create an image and use that image for next execution, and that is not possible practically, because every image we have understood that is every image is made up of a layer of images. At the same time, you should know that Docker is going to create the file system in each layer, and the file system which is available to the current instance, that is container, is the one which is on the top layer. And of course, if the directory is not there in the top layer, then it goes into the next layer directory structure. I mean, every container will have its own directory structure. Every image rather will have its own directory. So this is the concern which we have right now. Yes, my data is not persistent between different container instances. So by default, all files created in container are stored on a writable container layer. It means the data doesn't persist when the container is no longer running. And it is very difficult to get data out of container if the process needs it. And I told you the procedure is simple. I mean, the procedure is complicated. From the container, you have to get the image created by committing the container and then use that image for subsequent execution. And what is the issue here? The container writable layer is tightly coupled to the host machine where the container is running. You can't easily move data somewhere else. So these two are the major problems what we have now, for which we need to find solution, and the solution lies in Docker storage. And that's what we will see in the next session. Thank you.